All right, so now we are going to look at quadratic inequalities of the second method of solving quadratic inequalities, but this time using graphing method, which is much easier, and you're going to appreciate this way better. The steps for this is that the first thing we have to do, we have to look at the x-intercepts. That's the first thing we have to do. So this is a crucial part. X-intercepts, you still have to do it the same as what we did the last lesson, okay? Once we have the x-intercept, then you need to graph this. Okay, graph the quadratic function, and you have to be accurate in terms of your x-intercept because you just found it in part A. You really don't need to have the vertex in this case if you're not given that, but if you're given in a vertex form, then it's easier for you to just come up with the x-intercepts algebraically or graphically. So this is not necessarily, you don't have to solve for the x-intercept using algebraic method if you don't want to, but it's sometimes easier. And then once you have that, part C is that you look at the region of the graph that is above, which is greater than 0. All right, so this another way of writing it is that you notice that this would be greater than, equal to, or it would be greater than 0 or equal to 0 depending on how we are writing it, and then less than or equal to 0 depending on how it is. Okay, how we are looking at the part of the graph that is below the x-axis and part of the graph that is above the x-axis. So look at the, and then a final thing is that we have to write the interval solution the way we did in the last lesson, just the algebraic way. There's nothing else you can do about it. You have to use the number line and interval solution. All right, let's look at this example. We want to solve this quadratic inequality, and in this case I specifically and purposefully chose the vertex form. All right, so the first thing we have to do, we have to solve for the x-intercepts. Now, a couple of ways of doing this. You can actually graph this immediately, use the vertex, and you know what the vertex is. Vertex is 1 minus 4. Okay, so the vertex is 1 minus 4. I'm going to continue with this, and then I just made a point here that greater than or equal to 0 means above the x-axis all the values of x. So we can go ahead and solve this, and you can use graphing method. You can just graph this and look at the x-intercepts, and that's okay. You can use the leading coefficient. This is the leading coefficient right here, which is 1. That's your A, expansion compression factor, and go ahead. I am going to use the algebraic method to solve for the x-intercepts here, and then you do the graphic method to graph the function, and then we can compare notes and come back. Okay, when you go through the algebraic method, that's what you're going to get. Isolate the x squared bracket term, and then take the square root of both sides. You're going to get plus or minus 2 right here, and then the answer will be x. One value for x will be 3, the other value will be negative 1. All right, you got your x-intercepts. Now we're just going to do a quick sketch. Okay, that's exactly what we're gonna do, and I am emphasizing a quick sketch here. So 3 is here, eyeballing it, negative 1 is there, and we know based on the fact that this thing right here that we just talked about is above the x-axis, and the graph, because A is positive, this 1 is positive, the graph of this quadratic opens up. So I know that it's going to go past that x-intercept 3 and above negative 1, and it's going to drop somewhere in between, and you already know the vertex, but really you don't really know the exact, you don't need to know the exact value, but the vertex doesn't really matter. What matters is, or the two, your x-intercepts right there. And then when it says above the x-axis, that means the part of the graph that is above. Look, this is the above, that's the above. That means all of these values of x to the left of negative 1 and to the right of positive 3 are part of the solutions. So let's write up the interval. So the first one is all the values of x that are less than equals to negative 1, and it is less than equal, that means negative 1 is part of the solution, or x has to be greater than equals to 3. Excellent. So these two are actually part of the solution. And let me redo this because that was from another question. All right, so put them on a number line. The last thing that you're going to do, this is 0, -1, 3, shaded on a number line. This is a number line solution, shaded for -1. So to the left of -1, all the values of x works. To the right of +3, all the values will work. Okay, so that is how you show using graph of the quadratic function, and it is easier, as you can see. All right, very good. Practice time. Oh, one last thing as a review, making sure you have to follow these steps. Always follow the steps when it comes to solving quadratic inequality. First, you find the x-intercepts, then you graph it. Once you graph it, you don't really need the vertex form or vertex, as long as you know where the x-intercept is. If the graph is upside up, which is this one it is, then great. You just look at it, which part of the graph that is part of the inequality. Is it above x-axis or is it below the x-axis? And if it's below the x-axis, that could be less than 0. Okay, and then pay attention if it has an equal sign incorporated within the inequality sign or it's not. And if it is, then you make sure that your solution is inclusive with those x-intercepts. And if it is not, it's only strictly is greater than or equal to, then make sure that the solutions are not part of the x-intercept are not part of the solution. And that's basically it.